This video is a quick explanation about how to set up motion of a component. So again, I mentioned this in the lecture in case you didn't follow me. So first, let's quickly set up the base of this tool from the EOT, right? So go to the CAD file, select the amount we have. So then apply, you have to apply to show it right inside of software. So then here, again, just remind you, so for the base, remember we can set up the angle of it or the offset of this the EOT, right? So here I want the angle, which is a Z, right? Which is a Z here, right? This one. I want it to twist like 90 degree. Okay, so then click OK, you have this base. Okay, so then for the motion part, the moving part, right? So I'm going to have it under the EOT, add link, CAD file, select this draw assembly model here. So then, so first thing, so for the servo motor control, I will change it to the IO control. Therefore, in our case, it's IO control. Okay, so then I will apply here. So then you have this draw, okay, kind of inside of this base. Okay, so then the next thing is, okay, for rotary, right? So I don't want it to be a rotary movement, but you can try it by yourself. If it's a rotary movement, so then it will rotate along, I mean, axis you set, and then, but for us, we want the draw slide along one axis, so we are going to make it as linear. And for the speed, you can control it as like a speed, how long is from one point to the other, or just a speed, right? Set up a speed to it. Okay, so the other thing is, okay, so for this draw, now the orientation and the location is not right. Hope you still understand how to remember how to set up it. It's like you can drag, select this link, drag it, right? Or go to the like link CAD, remember, not general, but link CAD. So change the location. First it's Z location, yeah, but just remind you, make sure the link is selected, not something else is selected, right? So let's select the link, double check here is a link for setting up the link. See, make it like, I remember the value is 42. You can also drag it to align it. And then the angle is not right. It should be twist along the Z direct. Twist it 30. Okay, let's see. Okay, so now it's a left draw, right? So if it's the right draw, you can do it in a different direction. And also the Y, we need to set up it. I will drag it like this, so just inside of it, and I want the side of this part of the draw align with the part of the base. Okay, so that looks perfect. Then I'm going to click OK. So now then double click it. Sometimes I just click OK to make sure it's saved. Okay, so I can save the settings here. Then next thing, so I want to set up the motion for it, right? Here we have some tricky part. Some like, yeah, you need to kind of understand. You may confuse. So, okay, so first motion, I mentioned it should be a linear motion. Okay, so then let's first set up the control, right? So in the inputs I mentioned in the class, this is the input here is based on the draw's perspective. So it's an input for the draw. But when you select the controller, assign the IO, you see it's the output. Why? It's the output from the robot. For the draw, it's input. For robot, it's output being connected with this draw, right? So that's why. And for the value here is the number of this output pin, right? So you can use any pin hasn't been occupied. So I will, for example, use 2. Okay, so let's see. So and then you change, okay, when it's going to our location, it's on or off, right? So it's logic. So let's make it on. So go to, for example, 7, so or 10, millimeter. So the unit is millimeter, right? So which means, okay, it will along specific axis moving 7 millimeter when the output 2, digital output 2 is on. Okay, so we can, but it's not finished. We need to set up it when it's off, right? So of course you can use another like IO pin to control this, but it's just unnecessary. Also, waste of resources, right? So I still use the same pin, but set it when it's off, it go back to 0 or like 1 millimeter in some specific location. So let's test it. Okay, let's test. Okay, so now it's moving along the Z orientation, not like that Y orientation, right? So which is the tricky part. So should we set it to Y? And again, you need to apply. If you don't apply, it will not like really happen. So let's go back to the motion. So let's see if it's moving. Okay. So and also you have this giant like a part. Let me part general motion CAD file. So show collision. So servo motor. You need to kind of okay. Let's turn off this motor visible, right? So because you see, if you have this motor visible on in general tab, so you have this virtual motor kind of visible for you to know, okay, what's the XY direction like that to control. This is kind of a virtual motor show the force applied to this jaw. So apply. So you don't want the motor show up here. So now, okay, so back to the motion. When I test it, it's along the Y orientation. What happened, right? So we set it to, we wanted to move around this Y orientation. No, it moves like around the X axis. Correct myself. So right, so it's not from the along the Y direction, but the X direction. Why? Actually, because the X, Y here, you don't want to reference the jaw's coordinate system, but the base, because this is a part of the U2. So we want to set up this jaw along based on the U2's coordinator, or UT end of arm 2, the coordinate. So which means, okay, you see, when we collect the base, which is the U2, it has X, Y, and Z like this. So you want it to along the X axis. So let's go back to the jaw, lincat, not lincat, motion, general. Yeah, so select it to X, apply. So now, okay, so when you go back to motion, test it. Yeah, now it's along the, you see, the orientation you want, right? So, but then you can see another thing is the location here. No, it's not what you want, right? It's outside of this part. Of course, that's what not what we want. That's because you can either change the here, right? Change some value that you want, but actually, tell you the true reason. Also because, right? So the here for the U2, you see the orange is here, and we set the jaw to move like a 7 millimeter along the X direction, the positive orientation, right? So that's why it moves that way, which means, okay, now it's parked here, 0, right? So it's reference to the U2. So then here we should set it to like -7. So that way it will apply, it will, see, when you test it, it will, yeah, move from a reference, like based on the origin of that U2, go back to -7, right? That's very simple. So, and you can set up your the other jaw like this.